Hi class. Now that we know what a function is, we can start talking about describing the behavior of functions. We want to be able to talk with one another about a particular function and make sure that we're all on the same page. First of all, a little review. Is this the graph of a function? I look at this and immediately see that it is. Since I'm looking at a graph of a function, I'm applying the vertical line test. Every vertical line intersects this graph at most once. Where there's a vertical line intersecting the graph, which for this graph, there are 1, 2, 3, 4, 5, and 6 only vertical lines that intersect the graph. Every other vertical line in the plane doesn't intersect the graph at all. So I can't find a vertical line that intersects the graph more than once. We pass the vertical line test. This is the graph of a function. And by thinking about these vertical lines that do intersect the graph, each one of those is identifying a value in the domain of the function. So the domain here of our function would be -4 is in the domain, -2 is in the domain. This is about 1 here. 1 is in the domain, 2 is in the domain, 5 appears to be in the domain. I'm reading these approximately. And 7, that looks like 7 to me. So I would say that's the domain of the function. How about the range of the function? Let me just clear this. The range of the function, I can think of horizontal lines that intersect this graph. That horizontal line, which has a y-coordinate of 0, is in the range. So 0 is in the range. The next highest line that intersects the graph is right there, horizontal line. And that has a y value of 1, so 1 is in the range. The next horizontal line that intersects the graph is at 2. And the last horizontal line that intersects the graph is at 4. So those are the only range values. Those are all of the output values of this function. Now, here's a different function. Is this the graph of a function? First of all, let's be clear on why it's different. The previous example had just these highlighted dots. But on this function, there are a lot more points on the graph of this function. If I sweep this graph from left to right with vertical lines, the first vertical line that intersects the graph is at -4. As I move to the right with my horizontal lines, every horizontal line is intersecting the graph once and only once, all the way till I get to the last vertical line that's intersecting the graph. That's 7. So every vertical line between -4 and 7 intersects the graph exactly once. We pass the vertical line test. We can't find a vertical line that intersects the graph more than once. So this is the graph of a function. That answer is yes. The domain of the function would be every real number between -4 and 7, including -4 and 7. So it's the interval on the real number line from -4 to 7. all real numbers between -4 and 7, including the endpoints, -4 and 7. And what about the range? Well, like in the previous example, the lowest point on the graph is right here at an input of 2 when the output is 0. In other words, the lowest horizontal line that intersects the graph is right there at y equals 0. And now every horizontal line above that intersects the graph at least once until we get to the highest horizontal line that intersects the graph, and that's at 4. So the range includes all real numbers between 0 and 4, including those endpoints, 0 and 4. So domain and range give us the crudest way of describing the behavior of a function. The domain would be the set of possible inputs for that function, the set of all inputs. The range would be the corresponding set of all outputs. But now we want to describe how those, if any trends that we have in the data. And so one way we can do that is to talk about when a function's increasing, where a function's decreasing, and where it's constant. If we're looking at a graph of a function, we can say that f increases as its values increase as x increases. The graph rises. Here's an increasing function. Reading that graph from left to right, function values are going up. That's increasing. A graph decreases if the graph falls from left to right, if the function values decrease as x increases. So this would be a decreasing function. As we're moving from left to right, we're going downhill. And finally, a function is constant if its function values don't change as x increases. So in other words, the graph is horizontal, like that. So on what intervals is this function increasing, decreasing, and constant? Well, from that previous example, we can see that this function is first decreasing, then it's constant, then it's decreasing again, then it's increasing, and then it's constant. Remember, we're reading always our graphs from left to right. So let's write down where this function is increasing. Here, I'll write it up here. This function is increasing. Well, it's increasing on this chunk right here, which starts at a value of 2 and ends at a value of 4. Oh, no, not at a value of 4. Let me get rid of that. It ends right here. The increasing chunk ends right here at 5. So from 2 to 5, the function's increasing. That's what I'm going to write. This function is increasing on the interval from 2 to 5. We always describe a function's behavior by calling out the input values for which it does that behavior. The reason we go with input values and describe an interval on the input axis, the independent variable axis, is because that's the way to make sure that everyone's looking at the same place on the graph. If I say, look at this function that we're talking about on the interval from 2 to 5, on the input interval from 2 to 5, everyone's going to look right here. That's just a well-defined place on that graph. And so I can say this function is increasing on the interval from 2 to 5, and even if you didn't have this graph, you would know that between input values of 2 and input values of 5, the function's going uphill. So that's it for increasing. Where is this function decreasing? I'll write that right here. This function is decreasing. Well, it's decreasing right here. That's on the interval from -4 to -2. So that interval starts from -4 at -4 and ends at -2. So I'm saying that for all real numbers between -4 and -2, including those endpoints, the function's defined and going downhill. And it's also it's also decreasing right here. And that is from 1 to 2. So on the interval from 1 to 2. So far we've got the interval from 2 to 5, the interval from -4 to 2, and the interval from 1 to 2 defined, as far as it's the behavior of the function. And finally, where is this function constant? It's constant right here, and that's from -2 to 1, so that interval right there. And it's also constant right here, and that's from 5 to 7. 5 to 7. Now this function that we're looking at, I'm actually going to go to the next slide. The function that we're looking at, the next slide didn't have the graph on it anymore. So I'm just going to get rid of some of that, just so we can see it again. There. So this function, which has domain all real numbers between -4 and 7, notice that once we've defined where this function, which is continuous, I can draw it in one, I can draw it starting from the left. I can put my pen down and draw the entire function without lifting my pen. That means that this is the graph of a continuous function, and most of the functions that we're going to be looking at in this class are continuous on their domains. For a continuous function, if we describe where that function is increasing, where it's decreasing, and where it's constant, those are the three options. And so if we have done this correctly, we should have covered the entire domain of the function in writing these intervals. And we have. If we start from left to right, the function's decreasing from -4 to -2, and then from that -2, it's constant from -2 to 1, and then from that 1, it's decreasing from 1 to 2, and then from that 2, it's increasing from 2 to 5, and then from that 5, it's constant on the interval from 5 to 7. So we've covered the entire domain, and notice that if I just told someone that I had a function that was increasing, decreasing, and constant on these intervals, it would give someone the basic trends of the graph. It wouldn't tell them what the function values were. Where are we on the y-axis? You'd have to have more information, like you'd have to be looking at this graph, for example, to know that, or you'd have to have formulas for the individual pieces, and so on. We'll get to that as we move forward. And I've already talked about this. Always keep in mind the intervals on which we're talking about a function's behavior are intervals of input values.